All right, we are going to take a look at related rates yet again here in 2.6 day 2. I know it says 12 right there, but I mean day 2. I'm going to pause the video because I'm going to draw on this trough that is 20 inches long and 5 inches wide. And then as I slice this triangle with an altitude of 8 inches, if water is being pumped into the trough at 7 cubic inches per second, how fast is water level rising when the water is 6 inches deep? So again, I'm just going to pause the video to draw on. All right, there's the diagram, 5 inches wide, 20 inches deep, and then the altitude is 8. Pause the video if you need to go ahead and draw that in. So what we have here is a prism. Big B times H. Now the big B is just the area of the base. Now a couple things here. Little b over h is a little base over the height. Is this going to be 5 over 8? Which means base, the little b, is going to be 5 over 8 h. So with this problem, what we're trying to figure out is how high, or what is the altitude or the depth of the water when it is 6 inches deep. So that's what we need to take a look at. Your triangular prism that's V equals 1/2 BH times the length of the prism. So this is going to be 1/2 B, which is 5 over 8 H times H, times 20, because the length of it is 20. So I have 1/2, I apologize, looks like 100, 8 squared divided by 16. Now this is going to be 25 h squared over 4. Now I'm going to take a look at the volume with respect to time. Now we know that it's being pumped in at 7 inches per second, cubic inches per second. What we want to find is dH over dt. That's what we want to find. We know, we already figured it out, that the volume is going to be 25 h squared over 4. dV over dt is going to be equal to 25 over 4 times 2h times dH over dt. dV over dt equals 25 over 2 h dH over dt. Now we know what dV over dt is, that's 7. So 7 equals 25 over 2. Now we also know what h is in this case. We're being asked to find this when h is 6. dH dt. So 7 equals 25 times 3 dH dt. So divide, well, we know that this here is just 75, right? So 7 over 25 equals dH over dt. Number 2. A winch is being used to tow a boat at a dock. The winch is 15 feet above the boat and it pulls the rope at a rate of 30 feet per minute. At what rate is the boat approaching the dock when there's 75 feet of rope out. So I went ahead and drew the picture and paused the video to draw it in if that's something you need to do. So this distance here, the hypotenuse, I'm just going to call z. So dz over dt equals negative 30 feet per minute, because that's how fast I can pull in the boat. What we want to find, we're going to find dx over dt when z equals 75. Okay. Now, based on that, what we know is this. So we know that my height is going to be 15, hypotenuse 75, x is, or the base is x. So we can just use the Pythagorean theorem to take a look at this. So x squared plus 225 equals 5625. The reason I'm doing this is because I need to figure out what x is. X squared equals 5400. X equals 30 root 6. Now, now we're going to apply this information back to our original. So we have x squared plus 15 squared equals z squared. Now I'm going to derive this with respect to time. 2x dx over dt plus 0 equals 2z dz over dt. Now I know what 2x over, or dx dt is. That's 30 root 6. Or excuse me, that's what x is. I misspoke. So 2 times 30 root 6 dx dt equals 2 times 75, because that's when we want to find out is when this distance right here is 75, times dz over dt. Now dz over dt is negative 30. Now these 2's divide out. So if 30 root 6 dx dt equals 30 times 75, negative 30 times 75, which I think is negative 2250. Dx over dt is going to be negative 2250 divided by 30. Root 6 that is. And this is going to equal negative 30.619 feet per minute. Number 3, a 27-foot long ladder is leaning against the wall of a house. The base of the ladder is pulled away from the wall at a rate of 3 feet per second. Why somebody would do that, I don't know. Find the following rates when the base, that should be base, not BSE, base of the ladder is 10 feet from the wall. So there's your drawing. Now what we know is that dx over dt is going to be equal to 3 feet per second. Now we're going to find dy over dt when x equals 10 feet. So this is very similar to the last problem. Now the first thing we need to do, just like we did the last one, is we need to figure out what the value of y is when it's still 10 feet away from the wall and the ladder's not going to change as far as its length of 27. Now once you figure all that out, you find out that y equals the square root of 629. Now what I know, the only constant here is this ladder, it's 27 feet. What does change is your x and your y based on you pulling the ladder away. So I go ahead and derive this. So I have 2x dx over dt plus 2y over dy over dt. That equals 0. Now, I can divide everything by 2 right now. Just to make sure, just so I'm looking at smaller numbers. Now again, we're trying to find dy over dt. So I'm going to take the x dx over t and put it on the other side. So I have y dy over dt equals negative x dx over dt. You don't have to do that at this step if you don't want to. I'm just choosing to. Now, what is y? Y is the square root of 629. What is x? So negative x dx dt, what does that equal? Well, x is going to be, oh, I apologize, I need to put in a dy dt right here. This is going to be negative 10 times 3. So dy over dt is equal to negative 10 times 3, or negative 30, divided by root 629. And this is going to be approximately 1.196 is going to be the value of dy dt. All right, part B in this problem, find the rate at which the area of the triangle formed by the ladder and the wall is changing. So what we're looking at is this area right here. This is y, this is x, and that's 27. So we know that dx over dt is 3 feet per second. And again, because that's given to us in the original problem. We want to find dA over dt. Okay? When x equals 10. What do we know? We know that the area of a triangle is 1/2 base times height, or in this case, x times y. So dA over dt is going to be equal to 1/2 dx over dt, because if I take the derivative of x, I get dx dt, times y, plus dy over dt times x. Now, I'll go ahead and pause the video there for a second if you need to, just to kind of wrap your head around what just happened. So again, if I take the derivative of x, that's dx over dt times y, plus I take the derivative of y, that's dy over dt times x. You can go ahead and switch these if you want, but I just wrote it that way because I'm taking a derivative of y. Now let's put in the information that we know. dA over dt equals 1/2 times dx dt is 3, right? Y is the square root of 629. Plus dy over dt, we found out earlier, is negative 1.196. And x, we know, is 10. So I'm going to have 1/2 Now when you simplify this, you get 75.2396 minus 11.962. You simplify all this and multiply it by half, you get 31.639. Now it's going to be feet squared per second. That's what the area is as you're pulling the ladder away from the wall when x is 10. Find the rate at which the angle between the ladder and the wall is changing. X, Y, angle 27. So what are we trying to find? Well, we're trying to find d theta divided by dt. We know a couple things here. One of those is the cosine of theta is going to equal the square root of 629 divided by 27. We also know the sine of theta is going to be equal to x over 27. That's what we know. So now what I'm going to do is I'm going to take a look at this sine theta equals x over 27. Go ahead and take the derivative of that. The derivative of sine theta is cosine theta, right? So it's going to be cosine theta d theta over dt. Now that's going to be equal to 1 over 27 dx over dt. Now the cosine of theta, you know, is the square root of 629 over 27. D theta over dt. That's going to be equal to 1 over 27 times dx over dt, which we know dx over dt from the previous two problems is 3. So d theta over dt equals 1/9 times 27 over the square root of 629. Now we take 3 divided by the square root of 629, that's 0.1196 radians per second. A man 6 foot tall walks at a rate of 4 feet per second towards a light 25 feet above the ground. When he is 15 feet away from the base of the light, at what rate is the tip of the shadow moving? So I'm going to pause the video and draw that diagram in. So here's the diagram. The light's 25 feet above the ground, the man's 6 foot tall. So this whole thing is y, so this distance from here to the man, that's going to be x. And so what's remaining back here is this your x minus y. If you need to, pause the video to draw that in. We want to find dy over dt when dx over dt is equal to -4 and x equals 15. So when dx dt equals -4 feet per second, and when he's 15 feet away from the base of the light, that's what we're going to find. So we have a triangle here, actually similar triangles here that we can set up. 25 divided by y, height of the big triangle over the base of the big triangle, is going to be equal to height of the man divided by the base, which is y minus x. So go ahead and multiply, cross multiply. 25y minus 25x equals 6y. Now what that means, 19y equals 25x, which means y equals 25 over 19x. Now, I'm going to derivatize both sides. So this means I have dy over dt equals 25 over 19 times dx dt. So dy dt, dy over dt, is going to be equal to 25 over 19 times negative 4. So this is negative 100 over 19 feet per second. That is the rate at which the tip of the shadow is moving. Now my next question, it says, at what rate is the length of the shadow changing? So this is where you are going to take dy over dt minus dx over dt. Now this is going to be equal to negative 100 divided by 19 minus a negative 4. Now this is going to be equal to negative 24 over 19 feet per second. That's the rate at which the shadow is actually changing. That wraps up 2.6 day 2 and also chapter 2.